All right, I think we're going to get started. So welcome to AI504, Programming for AI. This semester, I'm seeing explosive number of enrollees or students who have enrolled for this class, and that number was about 360, and I'm only seeing 230 here. So I guess a lot of people will just drop out. So hopefully we'll get the number down below 300 because the Kai's Zoom license allows only up to 300 people in the same room at the same time. So if we have more than 300 people, then there will be some people who won't be able to participate. But then this semester I won't be calling I won't be calling attendance. So no attendance checking. So we'll just probably see less and less people as the time goes by. Some people want to record locally. I'm going to record this all the time and then upload on YouTube. So you don't have to record yourself. But if you want to, please go ahead. All right. So today is just introduction. So hopefully we can get this thing all done within 30 minutes and then end early. And if you have any question, please ask away. You can ask in voice in Korean or in English, or you can write down your questions on the chat box, whatever. It doesn't really matter. All right, I'm gonna allow anyone to locally record, so just go ahead. So what is AI? So because this is the name of the course is Programming for AI. So what is AI? So AI, I'm pretty sure a lot of people in this room already know what AI is, but for those who doesn't have a clear understanding or distinction between AI, machine learning, and deep learning. So here's just a recap. So artificial intelligence is, well, I mean, this is kind of like my own personal definition, but it's it's a effort, or actually it's just a concept. AI is a concept. It just is a concept that trying to make machines or computers mimic human intelligence. So this is human intelligence is also kind of like vague term. It's an abstract term. So AI could be anything that mimics any type of human intelligence. Like, some people have like a logical intelligence or emotional intelligence, linguistic intelligence, social intelligence, whatever. So it could be anything. So this concept is as old as the computer because Alan Turing, the maker of the computer, actually thought about a chess program that can play chess with a person. So that's already a type of AI. And the machine learning is a subset of AI because there's a lot of way to make machines or computers mimic human intelligence, and machine learning is one of them. So it's just a subset, but these days it's kind of like equivalent because there were other types of AI back in like 70s or 80s, but they all are not. I mean, there are still like effort other than machine learning to make AI happen, but machine learning is definitely kind of like the majority. So machine learning is using statistical methods to teach machines to learn from data to be good at a specific task. So here there are important words that are statistical methods and learn from data, right? So learn from data is the thing that makes machine learning distinct from other efforts to make AI happen. So, and it's actually to be good at a specific task is just addendum. So it actually should end right here, right here, to be good at something, rather than a specific task. And this has been around since, I don't know, I would say 80s or 90s. SVM came about in 95, 98. So, and that's when machine learning applications that really made presence in our lives, such as spam filtering. So spam filtering is a very simple form of machine learning. Some program reads your email, and then if it seems like a spam, then it goes to spam. It goes to spam bin, spam section, and if it looks like a ham, then it's in your inbox, right? And the way that the machine decides whether something is spam or not is by reading the words and then statistically calculating the probability that it's whether it's a spam or ham. So that would be machine learning. And then deep learning is within machine learning. So it's a subset of deep learning. So you obviously know other types of machine learning. I mean, SVM is like machine learning, but people don't call SVM deep learning. So deep learning is training machines to be good at complex tasks. So there's a distinction already. So there's a specific task and then there's complex tasks. So compared to spam filtering, ChatGPT is way more advanced than spam filtering. Actually, probably ChatGPT can do spam filtering for you, right? So training machines to be good at complex tasks based on neural networks and massive data. So there's 3 different words that come out here. There's complex tasks, neural networks, and massive data. So data was there, and statistical methods was there, and specific task was there. So statistical method becomes neural network. Data, just any data becomes massive data, and then some task becomes complex task. So that's where deep learning is. So basically, it's just using building a large machine learning model, mostly based on neural network technology, and then pouring massive amount of data into it to solve complex tasks that wasn't possible before the era of deep learning. So this is the hierarchy of AI, ML, and DL. So this is all basic stuff. So why deep learning? Like why has it become the standard of machine? Like these days, machine learning and deep learning are kind of like equivalent. I mean, there are definitely other stuff. As I said, like SVM there's like trees, like XGBoost. That's still very, very relevant, very powerful. But mostly it's about deep learning. So why deep learning? So if you look at the bar chart for ImageNet classification error, ImageNet, hoping that mostly a lot of you has at least heard about ImageNet. It's a data set for image classification, and it's given an image, you're supposed to classify the image into one of the 1,000 classes. So there's like a lot of classes, and 2012. So here, 2012 is when AlexNet came about, when AlexNet was proposed, and prior to that, the best error, so which is if you take 26 out of the 100, then that becomes accuracy. So the accuracy was about 74%, but then by 1 year, the accuracy increased by 10% point by AlexNet, which is the first neural network. And remember that there was no PyTorch, there was no TensorFlow back in 2012. So AlexNet, the main author, Alex Krizhevsky, had to write it in, I'm not sure which language he used. Maybe it was C++ or Python. I'm not really sure. But anyway, he had to write the backprop by himself, and then do the CUDA coding by himself, which is like a lot of work. And then since AlexNet came about, then it was the era of deep learning began, and then you can see the rapid increase in accuracy. So human accuracy is about 95%. Considering all the errors, people making mistakes, but now by 2015, machines were already outperforming humans in terms of ImageNet classification. So the last 26, it was already 97% accurate compared to 95% accuracy. So it's already outperforming. And I guess this is no longer relevant. So nobody really, tries to make 1 or 2 more percent accuracy increase in ImageNet. Maybe some people, but this is definitely not the majority. So you can see the performance difference from here, which is not deep learning, and this is definitely deep learning. So 74% accuracy to 97% accuracy. So if neural network technology wasn't there, then you would probably not see this kind of gap between the two, right? So that's the power of deep learning. It's the performance. So it's not just theoretically like attractive or like mathematically beautiful. It's not none of that. It's very, very powerful. In reality, it actually performs really, really well. It's all about practicality. And another really good thing, again, like another practical reason for using deep learning is that it doesn't require much of feature engineering. So before deep learning, so this is the classical machine learning process. You have an image. So let's say that you want to classify an image either into dog or a cat. So it's a dog or a cat classifier. So it's a binary classification. And so given an image, how would you design a machine learning model to decide whether something is a dog or not? That before deep learning, what people did is you had to be really good at image processing. So it required domain knowledge, and you had to think about what dog is, like dogness is, what the property of the dog is. Like dogs have like eyes and colors that are distinct, eyes, colors, nose, fur, ears, tongues, that are all distinct from cats, right? So you would have to think about the features of the dog and then write it in code, and then use that as a feature for training your machine learning model, like SVM or logistic regression or random forest, whatever. You had to create the input feature vector. And that is a lot of work, basically, because if your performance is not really good, then you have to re-engineer the feature again and then train it from bottom again, So that would be the standard way of doing machine learning practice back in the day. But since deep learning, people don't really care about feature engineering that much. I mean, people still care about feature engineering, but not as much as before. So if you think about ResNet or InceptionNet, you just pour image into the model and then that's it. You actually care more about designing the model architecture rather than feature engineering. So that is kind of like became equivalent. So if you have a well-designed model and then you have massive amount of data, like a million different images, then you just pour that image into the model and then do a backprop, with the label, then the machine will automatically figure out the features for you. So the model, actually the machine does the feature extraction and classification at the same time. So you don't have to do feature engineering as much as before. So that's another practical reason why deep learning is so popular. So that is why before deep learning, there were domain experts in all different fields. There was computer vision expert, there was NLP expert, there was like audio expert, there was, I don't know, like time series expert, like every different field had an expert, because before deep learning, feature engineering was really important. And you would be able to do feature engineering well only if you are the domain expert. So if I'm an NLP expert, I won't be able to handle images as well as the, image domain expert, like computer vision expert or image processing expert. So all those like domain expertise really mattered. But since deep learning came about, it doesn't really matter as much as before. If you have enough data, then you can just simply design a model and then pour data into it, and then the performance will be really good. Like even if you can't speak, French, for example, all you need to do is just if you want to develop a English to French translation model, then all you need to do is just get your hands on English-French parallel corpus, for the training data, and then train a sequence to sequence model, and that's it. You don't have to be able to speak French to develop English to French translator. So because you don't need to do any feature engineering, you just put data, you just tokenize the data and then put it into your model, and then do a backprop, log likelihood, and that's it. So that's another powerful feature of deep learning. One is the performance, another is less or definitely more nearly no feature engineering. And how is this possible? So why wasn't it possible to do this type of thing? Why people did this before deep learning? So back then, there was not enough data and there was not enough hardware or compute to make this happen. So if you remember this requires neural network and massive data, right? So we need massive data to make deep learning happen. And thanks to the internet and the web technology, people can easily crawl or collect data from the internet. And then, ImageNet was also part of that. So there's social network services, YouTube, Instagram, and Twitter. Like people upload images and videos freely for free. They're providing data for free, and all we need to do is just scrape them from the internet. And then there's like a very well-maintained knowledge base or database, such as Wikipedia or news article. They also freely let you read their article as long as you watch their advertisements, the promotions, right? So it's like collecting data is much easier than like back in the 90s, for example, when the internet wasn't a thing. And powerful compute. So if just having large amount of data is not enough, because you need to have a very powerful hardware, basically processing power to train neural networks in a reasonable amount of time. So if it takes you to train like a single ResNet with 1 million images, if it takes like 1 year or 2 years, nobody's going to do that, right? So you need to be able to train it within like weeks or maybe even days. So, and thanks to all the powerful hardware such as TPU, these days there's like H100 is probably the best machine learning GPU out there. So, and you know how, and it costs a lot of money. So A100 is about $15,000. In Korean, it would be 2천만 원쯤인가요? And H100 is like $35,000. So that would be like 5천만 원쯤 하겠네. Right? So the hardwares are getting more expensive, and it's really hard to keep up with large IT companies doing machine learning research. Compared to that, like academia or small time labs or small institutions, they don't have enough money to buy like thousands of H100, like Samsung or Naver or Google or OpenAI, right? So anyway, so hardware is definitely powerful, but it's getting more expensive. So modern AI can do a lot of weird stuff. It can beat people in Go, which was considered like, machines would never be able to beat humans in Go because there's like too many possible choices. But that was not the case, back in 2016, was it 2016? Yeah, back in 2016, there was a big moment where AlphaGo beat 이세돌 사범님을, 네, 4대1로 이겼죠? Yeah, 4-1. And style transfer, like this kind of thing, style transfer was never going to happen with non-neural network technology. Like this is all thanks to deep learning technology, that you can translate the style of your image from photorealistic to this looks like Munch's. This looks like I don't know. Like this looks like modern abstract painting. This is definitely Van Gogh. You see here the Van Gogh style. So anyway, like this is a very complex style. You need to like recompose all the pixel information, but while keeping the semantics, while keeping the buildings, the whatever this is, like the walkway, the river. You need to keep all that, and then just change the style, which is very, very hard to do. If you ask like normal people to do it, they won't be able to do it. You need to be a really good painter to do this. If you think about the complexity of this task, and it can do translation, it can do object detection. This is a facial detection. There's like all kinds of movie stars and celebrities. So this can be done. And even more recent use is definitely ChatGPT and GPT and all that. So if you know about the history of GPT 1, 2, 3, you would know that when training GPT-3, OpenAI used like thousands of V100. So V100 is the prior model to A100. So there was V100, and there's A100, and there's H100. So back in 2020, when OpenAI was training GPT-3, they used probably more than 1,000 V100s, which is still very expensive, and 570 gigabytes of text. So probably like entire internet. They just use like some data set called Common Crawl. So it's basically all internet. So it says 400 billion tokens. So in Korean, that would be what? 4천억 단어 비슷하게 생각하시면 되겠습니다. And then so by combining the powerful hardware with truly massive amount of data, they trained a really large network, which has 175 billion parameters. So 175 billion learnable parameters. If you think about logistic regression with 10 variables, that's 10 parameter model. Compared to that, this is 175 billion parameter model, right? And it's assumed that the training cost is purely for electricity. What it costs $4 to $5 million. 그러니까 전기세만 한 60억, 50억, 60억 들었다는 얘기가 있습니다. So the modern scale of AI or deep learning is truly, truly impressive. Then so based on that, now we live in the age of large language models. So we have like ChatGPT, we have GPT-4, we have Bard, we have Claude. From Naver, we have Hyperclova X. There's like a lot of LLMs out there, and even the open source ones like Llama 2, they're all like LLMs. And so, in my estimation, they're probably the most powerful near AGI. So if you know what AGI is an AI that can do a lot of different tasks without going through like, making a significant change to the model architecture or training with a like new data set or something like that. It's like basically humans are AGI. Once you reach a certain age, you can do a lot of different stuff, or you just need like a bit of a teaching to make you good at some stuff. So LLMs with prompt engineering and like fine tuning and all that, like and a lot of different techniques such as like chain of thoughts and tree of thoughts, or making it into auto GPT. Like with some techniques, it can do like a lot of interesting stuff. So this is an example that I really like. So a journalist from SBS, Korean Broadcast Channel, journalist took GPT-4 and had it solve 2023 Korean college entrance exam. This is linguistics. So 이제 언어 영역인 거죠. 언어 영역. 저는 그 옛날에 수능을 봐서 모르겠는데 요즘은 언어 영역도 뭔가를 선택을 하는 게 있나 보더라고요. So 이제 선택을 왁박과 장군을 했다고 합니다. So a subsection, like some category of linguistics in college entrance exam, and it got 40 out of 45 problems correct. So that's about 88 points, and based on the EBS statistics, that amounts up to the top 17%. So top 17% is actually a very, very impressive score. Like it's a phenomenal score actually, because GPT-4 was mainly trained on English, but it can solve Korean college entrance exam and still be in the top 17% place. So that means that out of 100 high school graduate students, 83% are inferior in understanding text and then inferring text compared to GPT-4, which is either encouraging or discouraging. It's your take. If you think that it's still great that at least 17% people outperform GPT-4, then this is good news. If you think that already humanity is doomed because majority of people are not even, majority of people are inferior to GPT-4, then that's bad news. So, but if you look at this chart, this might seem like a good news, because if you look at this chart, this is a chart where this is a comparison between GPT-4 and ChatGPT being GPT 3.5, and GPT-4 is the green bars, and it's across all kinds of exams. So aside from the mathematics exams such as like AP Calculus or AMC or Code Force, right? Code Force, this is coding. So these are complex, and this is probably, it needs a bit more time to make this happen. But other than that, like bar exam, this is lawyer exam. So uniform bar exam is kind of like 우리나라 변호사 시험하고 똑같습니다. 변호사 라이센스 시험이에요. 이걸 통과해야지 변호사 자격증을 주는 겁니다. And there's like chemistry, physics, statistics, LSAT. LSAT is the law school entrance exam, and they're like across the board. Is always in the top like 80%, 90%, maybe even like 99%. So that means that most people are inferior to GPT-4 in all these tasks, all these exams. So this is like nothing. Like this is just college entrance exam. Attorney or lawyer license exam, this is in the top 10%. So it means that compared to most lawyers, GPT-4 is like likely to be a bit more, or actually far more superior. But this is just exam, so you don't really know. And so that was LLM. So there's like another generative model that is taking the world by surprise, which was, well, actually that happened a couple of years ago, which is diffusion model. So DALL-E 2, DALL-E 2 is from OpenAI, Imagine is from Google. Stable Diffusion is the open source version of text to image generation model. So this is a combination between diffusion and transformer. So transformer understands the input text, and then diffusion is the technique that generates the image. So you can see that the quality of image is just phenomenal. You can see that like the metallics, the texture is just right on point, and it's so well aligned with the input text. So astronaut riding a horse in a photorealistic style, chrome-plated duck. This is the chrome-plated duck with a golden beak. So there's golden beak, arguing with a golden turtle in the forest. So everything just all very high fidelity. This is from Stable Diffusion, so photograph of an astronaut riding a horse. So this is as good as DALL-E 2, or maybe even better. I'm not it's really hard to compare the style or the the image. It's all subjective, but at least that if by looking at this is very well aligned with the input text, and the image is I think it's almost as real as real photographs. The reflection is all here. The muscle of the horse, the dust when it's running there, it creates dust. It's all there. I'm sure a lot of you actually use Stable Diffusion to draw whatever you want. And apart from that, a lot of interesting phenomenal things happen. AlphaFold 2 is a DeepMind's protein structure prediction model. So before AlphaFold 2, protein structure prediction has been around for a very, very long time. When the chemistry, not the equation, the chemical structure of a compound or some material, it's really hard to guess their 3D structure just by looking at CH2 whatever. By looking at that string, really hard to guess the 3D structure. But AlphaFold 2 actually can do it just by giving it the chemical formula. Then it can actually really accurately guess the 3D structure. And this is really important because it's really useful for designing new drugs, or trying to test whether something is effective in the small molecules. AlphaFold 2 can accelerate the kind of research. And this is all based on, so if you look at LLMs or GPT-3 LLMs, DALL-E or Stable Diffusion, they all have transformer inside. This is also based on this is called evoformer, but evoformer is kind of variant of transformer. So this is all based on transformer actually. And transformer it looks like a difficult architecture to implement, but in reality it's really, really simple stuff. So you have many layers of transformer. Typically in GPT-3 used 96 layers of transformers. So there's transformer 1, there's transformer 1, transformer 2, and then there's 3, 4, 5 all the way to 96. So each layer looks exactly the same as the other layer. And the important thing in each layer is something called self-attention. So self-attention looks like this, which is a repetition of something called scale.product attention. And scale.product attention looks like this. So during and after this course, hopefully you will be able to, if you follow the course material, well, then you will be able to implement this and implement this and implement this, and then you'll be able to implement this or this or this or this in theory, because even if you are able to implement it, we won't be able to train it because you don't have thousands of V100s, but you will be able to at least write the code and then replicate it, because that's what this course is about. So this course is about learning to build deep learning models. So it's about implementation. So that you can replicate papers. So when you're doing AI research, you constantly read other people's papers. So when you read the paper, you should be able to replicate it. That's the beginning of any research, actually, copy pasting. So, and not all papers release their code. So you are going to have to replicate yourself. You are going to have to implement the model yourself. And hopefully this course will let you be able to do that, will help you be able to do that. So that, and replicating papers, and obviously realizing your ideas. If you want to build a new model architecture, you should be able to write it in code. So this course will help you do that. And basically, based on these two, you can conduct AI research. So this course, this is only a one semester course. So this course teaches only the very basics. If you've already checked out the weekly schedule. Those are really, really fundamental stuff. So you should practice by yourself. Practice makes perfect. So the structure of the course goes like this. So every Tuesday is a theory class. So it's a lecture class. So, and every Thursday is a practice class. So you learn theory on Tuesday, and then you practice it or you implement it on Thursday. So, and then this repeats every week until the last week. Evaluation is a letter grade. So I was thinking about changing this to pass or fail, because I think that's more aligned with the goal of this course, which is just letting you write codes in PyTorch. So I think pass or fail is a more appropriate, but unfortunately, I couldn't change that in this semester, but maybe 1 year later, I'll be able to do it. So it's a letter grade, and there are 3 projects. So far, a lot of things, there are some changes to this course compared to what has been done before for the past 3 years. Yeah, past 3 years, 2020, 2021, 2022. So before it was only 2 projects, but now we're using 3 projects. So it's 3 projects, 30%, 30%, 40%, and we're not checking attendances. So there are 360 people in this course. No way we can check the attendances. So and then it's up to you. You don't have to come if you don't want to. So we're going to talk about that, actually, the evaluation criteria. And the 3 projects will be image synthesis using GAN, language modeling using transformer, and then visual language model, visual LLM in the last project. So we're going to build up to a visual LLM. So this is for image encoding, this is for text decoding, and this is for multimodal decoding, I guess. Multimodal input, text decoding. And all projects will be given 24 hours to finish. And don't worry, so it doesn't take a lot to actually finish. If you can write PyTorch code, it'll take less than 2 or 3 hours. Definitely less than 3 hours, maybe 1.5 hours or 2 hours. And the training will only take 5 minutes on Colab. So because we don't care about training. We don't care about the model performance. It's all about implementing the model. So all these projects are designed to evaluate only model programming, not model performance. Once you build your model and it runs, if it trains, then that's good enough. So you train it, and then you train it for only 1 epoch, or maybe less than 1 epoch, maybe 10 iterations, like very, very small amount of training time, and then you submit that to the TA, and then we're going to compare the output results with the TA's result, who has gone through the same step, and if you pass, then it's a pass. So 24 hours. So we're going to give you 1 day to do this. So the weekly plan is like this. So there's a slight change compared to the original syllabus. So weekly plan, intro NumPy, basic machine learning. Then there's PyTorch intro, autoencoders, VAEs, GAN, CNN. Then comes the first project, and then so that would be the project 1 week. And then after that we go. So this is all kind of adding up to like image synthesis or image generation. And that next part is NLP part. So word2vec, RNN and sequence to sequence, transformers, and BERT and GPT. After that comes project 2, language model. And then 14 and 15 are more modern stuff, more up-to-date stuff. Diffusion model, DDPM, and image text multimodal learning. So, and then comes project 3, the visual language model. And there used to be graph neural networks somewhere in here in the original syllabus, but that's taken out so that we can do 3 projects instead of 2. But I am going to upload graph neural networks, and actually there's something called neural OD that was only taught in 2020. So I'm going to upload them on YouTube. I mean, actually, they're already there on YouTube. So I'm going to provide a link for you so that if you're interested in these 2 things, you can watch them on your own time. Well, I won't be teaching them this semester. So expectations, lecture attendance is up to you. 360 people enrolled in this class. No way we're going to call the attendances. And actually, you don't have to come once the entire semester if you think you're good enough to pass these 3 tests. If you're already good at PyTorch, you don't actually have to take this course at all. I recommend that you spend your time to something more worthwhile if you're good at PyTorch. But if you're here for the grade A without spending any effort, then that's also cool. You don't have to come. So, and Actually, I've uploaded the last year material on my website. So if you go there, then you can check out the last year material from AI504 from 2022. So everything's there. The codes, the syllabus, the YouTube videos, they're all there actually. So we might as well do flip learning this semester. If anybody's familiar with flip learning or not, then flip learning is something that I'm not sure. 총장님이 영어로 뭔지 모르겠네. 그러니까 총장님이 이제 격려하시는 학습 방법이 뭐 교육 방법인 거죠. Flip learning. So flip learning is you upload the teaching material online so that the students can look at it in their own time, and then during the course, during the class, during the lecture, we only discuss the material, Q&A, quiz, discussion, whatever. So that's flip learning. So I guess it's believed to be a way more superior teaching technique compared to just me coming here every Tuesday and then just me reading material, and then you just sitting there and just absorbing what I'm reading. So that would be the traditional learning. Flip learning is the other way around. So you learn in your own time, and then during the class, we talk about what you learned, or we talk about what you didn't learn. So that would be the flip learning. So maybe we can take a poll after this class if that would be more appropriate. Is there any like opinions or thoughts about doing flip learning this semester? 플립 러닝을 해보신 분이 계신가요? 그러니까 뭐 해보셨다기보다 플립 러닝을 하는 강의를 들어보신 분이 계신가요? No one? 아, 네. Some people like it. 네. 어땠나요? 이충희님? 어떠셨나요? 네, 딱히 뭐 대답을 하고 싶지 않으신 거 보니. 아, 네네. 아, 네. 학생들이 준비도에 따라 소클릿 차이가 많이 났습니다. 그건 당연하겠죠. 미리 듣고 온 사람과 안 듣고 온 사람이 하는 질문들과 뭐 디스커션들은 당연히 수준 차이가 나겠죠. 네, 사실 배우고 싶은 사람만 배우는 겁니다. 아무도 뭐 이거를 때려가면서 학생을 가르치는 뭐 그런 초등학교, 뭐 고등학교가 아니기 때문에 뭐 알아서 배우는 겁니다, 원래. So yeah, I think some people like. I think there was a fan who said he was a fan. So maybe we can do a poll after this class against everyone. Oh yeah, William Arnold. Yeah. Question from Masa. Is it like you will tell us the topics beforehand? I've already told you the topics. These are the topics, and if you go to this website, you will get the entire YouTube playlist for all the courses right here. 아, 네, 상윤님 의견 감사합니다. Yes, so I was thinking about doing flip learning since I have all the material already. But then some people just like sitting during the lecture and then listening to what I talk. So I think there are pros and cons. So we can do a poll, and if enough number of people, I would say enough is not like 51% is probably not enough number of people. Maybe like 70 or 75% is like enough number of people. So we'll see about the poll result and then decide how we're going to conduct this semester. So, and about the 3 projects. So as I said, all projects are given 24 hours to finish. This is obviously individual effort. The goal of this course is to make you be able to write code in PyTorch. It's not about team effort. It's about you being able to write codes. So if caught, it will lead to serious consequences. The reason that I'm actually changing the structure of this course to 3 projects with different topics is because there were so many people cheating in the last semester, and we caught a lot of them. And then we didn't turn them to the ethics committee, but still it was a big problem. So actually we're changing the structure because of that, so that you can at least, we can evaluate whether you are really learning to code in PyTorch rather than just copy pasting from other people's code or just downloading stuff from the internet. So deliverables will be your code and your output, which would be images for project 1, tokens for project 2 and 3. And we are going to give you the template of the code so that you can fill in the blanks, or more than just blanks actually. So we already have a plan. We already have a pretty solid plan. So we're going to implement it this semester and see how it goes. Right. And oh, I forgot about the grading. You will be, so if you will be able to get A+ only by participating the course and answer. So from time to time, I'm going to ask questions, or you can ask questions, whatever. But from time to time, I'm going to start to asking questions, or asking stuff to the participants. And if you answer, then you get a bonus, and that's how you get A+. Just by doing 3 projects, the maximum score you get will be A. And if that's enough for you, then you only need to spend 6 hours or 9 hours the entire semester and get an A. That would be a really efficient way to get an A for you. If you're already good at PyTorch and you don't want to come to attend, you don't want to come to class, you don't want to do anything so you just want to focus on your research, that's good. You can still get an A by just doing these 3 projects, which will be really easy for you, and which would take only 6 to 9 hours the entire semester. If you want to get an A+, you should come to class and then engage. And the materials, there's a material. I've actually uploaded everything here, actually. And of course, this semester as well, I'm going to upload all the slides on Classroom. So beforehand, before the class. If we're going to do flip learning, then I'm going to have to give you all the slides as well. Actually, I forgot to upload my slides here. There's only videos and codes and syllabus. So I don't have the slides yet. So I'll upload that again. Question, will this course be offered online? Yeah, this will be offered online only. If we're doing flip learning, might as well just do online learning. And one thing that you guys must do after this class today, after this lecture today, is joining this Classroom page, or what? I don't know what to call it. This Classroom page. So please use this link to register yourself to this course's Classroom page. Could you give us some information about how strict, generous grades will be given? The grades will be, if you can implement these 3, you will be able to get A. There is no score difference, because it's about passing the minimum bar. So if you pass the minimum bar, you'll get an A. If you don't pass the minimum bar, but you still somehow manage to train something, then you'll get a B. If you submit anything at all, you'll get a C. If you don't submit anything, then you'll get an F. And then there will be a weighted sum for 3 to 4 across these 3 projects. So that's it. Very, very simple, grading scheme. Right, so the teaching team, lecturer is myself, obviously, and TAs are to be determined. How will the score be evaluated when our code will follow the step? Step is not important. It's about comparing the output from the TA's output with your output, and that's it. We'll give you like a margin of error, but there should be no margin of error because we're going to fix everything to the very detail. So we're going to give you all the hyperparameters, so there can't be any difference actually. No, I said participation not in terms of like actually doing 출석 체크한다는 얘기 아닙니다. We're not going to call attendances. Just by I'm saying that you attending the class and then engaging with me during the class. When I ask questions, you should answer, you know. So I'm going to throw out a couple of questions. Yes, yeah, I'm going to throw out a couple of questions every now and then. And if you answer them, I'm going to remember your name and record it, and then you'll get a plus, whatever. If you get a B, you'll get a B plus. If you get C, you get a C plus. If you get an A, you get A plus. So if you're lucky enough, you can attend just one class during the entire semester, answer my question, and then get A plus if you're lucky enough. So I'm trying to give you maximum freedom to all 360 different people. Right. So teaching team, as I said, it's myself, obviously. If you are interested, if you're curious who I am to teach you PyTorch, then you can go to this website to know more about me. Teaching team, hopefully we'll get maybe 6 or 7 TAs so that we can manage 360 different people at the same time. And myself, short introduction, I got my PhD in Georgia Tech, and my research area is healthcare AI. So you can read my thesis name is Interpretable Deep Learning for Longitudinal Electronic Health Records. So it's about developing deep learning models to handle medical records and then making it interpretable. And I've gone to various different places. I've done my military service in ETRI, 한국전자통신연구원이죠, ETRI, and then I've done a couple of internships at Sutter Health, DeepMind, Google, and then I was in Google Health and Google Brain before joining Heist for like half a year, a year and a half. And then my current research area is machine learning, healthcare, NLP, multimodal, mostly healthcare NLP, like clinical NLP stuff. And yeah, if you're interested about my research in more detail, you can go to this website and look it up yourself. And the first assignment, this is not an assignment, but this is something that you should do, which is installing Anaconda. So all practice sessions will be conducted on Google Colab. Google Colab is a very, very generous platform that lets you use their GPU for 12 hours straight without any constraints. I mean there's like storage constraint, but apart from that, it's very, very flexible. You can do whatever, you can train whatever you want on Colab with a moderate GPU. It's not as powerful as 800 or 800, but it's like, I think it's called something called T4, which is good enough for you, which is good enough for practice sessions and projects and all that. So all practice sessions and projects will be conducted with Google Colab. But as I said, this is session based. So every 12 hours, your progress will be gone. So if you don't like that, if you want to test something locally, then you should install something called Anaconda, which includes everything you need in this course. Jupyter, NumPy, scikit-learn, TensorFlow, PyTorch, everything is there. I mean, TensorFlow, we don't need this, but it'll install it for you anyway. Right. And questions. So there were some couple questions. Does this class do relevant? No, this is absolute evaluation. Yeah. But we are a lot of people, won't be difficult to engage for all of us. I don't plan to engage with 360 different people. Yeah. So I'm hoping that after this introduction today, people who are not interested in learning PyTorch will actually drop out, and then people who are actually interested in learning PyTorch will stay, so that we can cut down the number to below 300. But if not, that's still fine. Using Google Colab is still enough to follow the lecture? Yes. Actually, as I said, all the practice sessions every Thursday will be using Google Colab. I can't provide GPUs for 360 different people. Thanks to Google, though, we can use your GPU for free for 12 hours. Can I get the bonus if I answer you just in the chat? Yeah, you don't have to use the mic. Yeah. I'm assuming that as time goes by, maybe 50 people will come, and then it will be a really wholesome class. We can really engage. Answer by chatting would be also participation. Yes, answer by chatting is also participation. 요일은 안 정해져 있습니다. 화요일 해도 되고 목요일 되는데 1, 3이 중간 기말고사 중에 있는데 오늘에 대한 정해. Yeah, we'll figure it out. It's either Tuesday or Thursday, the usual lecture day. 코파일럿 같은 프로그램, 파일럿 같은 프로그램 쓰다가 치팅이 걸릴 수도 있어서. Yeah, we'll take that into account when we are announcing the project specs. Thank you for the tip. Yeah, already people are diverging in their opinion. Some people want Thursday, Tuesday, some people want the weekends. Does that mean we are already going to start implementing from this Thursday? Yes, but this Thursday is very simple stuff. If you have looked at the weekly plans, it's just NumPy. So we're just going to practice some vector manipulation and matrix manipulation this Thursday. You're not actually going to learn PyTorch, implement PyTorch before the third week. So the second week, the week 2 is not PyTorch. Week 2 is basic machine learning and using scikit-learn. 홀 코드를 스켈레톤 코드에서 완성하는 방법입니다. 왜냐하면 그렇지 않으면은 퀄리티를 컨트롤할 수가 없기 때문에. Skeleton code, as I said, we're going to provide a skeleton for you. For any reason why? So that we can, I mean, as I said, 3 hours is more than enough. So when we need to finish this in one day so that we can evaluate, and then if there are claims, we can work with the claims and all that. And it's another way a precaution to prevent cheating so that you can work on your own within a single day on your own at your place. All right, so any more questions? We also use another online GPU sources like Kaggle. It has around. You can do it for your own practice, but the projects must be done on Colab because all the PyTorch version, NumPy version, Python version, the GPU CUDA version, the GPU specs, they all need to be exactly the same so that we can evaluate 360 people. Oh, yeah, I'm not going to do that. Yeah. You can figure out the dates on your own time. 과제 날에는 수강생들이 다 같이 공부를 24시간에 각자 과제 주소. 네, 맞습니다. 강의의 prerequisite. That's a good question. There is a prerequisite, which is you need to be able to work with Python pretty well. So hopefully you've already taken data structure, maybe algorithm. I don't think algorithm is heavily required in this course, but at least data structure is going to help you a lot because you need to write the codes. So, being good at Python and basic understandings in data structure would be the prerequisite. If you don't know how to write codes in Python, you shouldn't be taking this course. If we version control our project, we need to use a private repository, right? Or is version? Oh, if you, yeah, I don't think, you're worried that some people might copy your code if you use a public repository, right? I don't think that'll happen, but whatever you feel convenient or comfortable. Is there any minimum? As I said, we're going to do everything in Google Colab. So there's already GPU, there's already memory there. All the material in this course will be designed so that it will be runnable on Google Colab. 12월 말에 전에 이 수업 끝납니다. 그러니까 걱정하지 않으셔도 됩니다. If you have a exceptional circumstance, for example, like you're sick or your parents are sick or your grandparents are sick or your kids are sick, basically any exceptional circumstances, then we'll make an exception for you. Designated, is that an official policy of the school? As I said, we're going to discuss this and we're going to pick a time and then announce it. There are already three different opinions. Some people wanted Tuesday, and now there's Thursday, and then there's weekend. So obviously people can't agree. 네, 알겠습니다. I mean, if you're the kind of person who goes to Europe's conference, then probably you don't need to take this course. I'm assuming actually more than 100, maybe 150 people, maybe even 200 people are here for the easy grades. So, and those are not the people that I want to engage with. But I'm pretty sure, I'm sure that at least like 50 to 100 people are really here to learn PyTorch because they need to learn it in order to conduct AI research. So for those people, I'm interested in. But as I said, I've opened up, so 360 people are here, so it's up to you. I'm going to give you maximum flexibility. As I said, no attendance check, easy three projects, and easy A by spending 6 hours the entire semester. So which is a very good deal for people who are really good at PyTorch. Right. Any other question? I think we've gone 1 hour actually. All right. I guess there are no more questions then. If you do, but you can always upload your question, post your question on Classroom, and then either myself or the TA. I mean, TA is not here, but in the future, TAs will respond, and so that's how we can keep communicating. All right, everybody, thank you for attending for the first class. This Thursday, it'll be NumPy session. So please come. If you don't know what NumPy is, if all you know is Python and nothing else, you've never done NumPy, you've never done scikit-learn, please come. Without that, you won't be able to write codes in PyTorch. So if you miss class one, if you miss practice one, the rest of the sessions will be too complex for you. So or you can watch the video and then practice on your own time. That's also good. But still, at least do practice one so that you can keep up. Right? Would all the class be recorded? Yeah, the class will be recorded anyway. Yeah, all the classes will be recorded. So that is why you don't need to come to class not even one time, because you'll be learning on your own anyway. Okay, so I'm guessing there are no more questions. So I'll see you guys this Thursday. Thank you guys. Bye-bye. 네, 감사합니다. 네네, 감사합니다.